All right.
Is it recording now?
Yeah.
Nice. Hello. It's Mr.
Wait, I'm zooming. Way in on
wanna
your
zoom in?
face. Nice. Some good camera work by me.
Is that good? All right. So we're going to start today talking about the prologue, which starts on page 4. So if you open your book, if you have it, or your handout to page 4, and
This sort of thing ain't my bag, baby.
it's the first page in your packet. It says the obvious view. You see that? Yeah?
No, sorry. You can spin your desk and then just have it face that way.
You know what that is? That's a galaxy. That's right. So, basically, here are a couple of humans looking at a comet. Have you ever seen a comet in your life? Probably not. Has there been a big comet around in the last recent? I don't think so. Anyway, here's a couple of humans. Of course, humans are very small, and there's our planet. Our planet's pretty big, isn't it? The Earth. And, of course, our planet is in a solar system, which includes a bunch of planets going around the sun in an orbit. And so we call that the solar system. But our solar system is just a tiny part of a galaxy. A galaxy is a huge collection of stars, very big thing. And the galaxy is just one tiny part of the whole universe. Because we think, or we know, we've seen through our telescopes, there's at least about 100 billion galaxies in the universe. And probably a lot more than that. Those are just the ones we can see. So, it's a big place we live in. There's the Earth. Did you know this is the most published photograph in the history of humans?
Yes.
You know, it was taken by a spacecraft, Apollo something, 16 or something like that, coming back from the moon. And it's the only time they ever photographed the Earth where the sun was directly behind the spacecraft, so it appeared full, kind of like when the moon is full. Because normally when you're coming back to Earth, the sun's over to the side and only half the Earth is lit up. It's not easy to get a picture like this. They don't have spacecraft that far away from the Earth that have cameras on them that are pointing at the Earth. That doesn't happen very often. All the satellites and such that you hear about that orbit the Earth, they're orbiting very close to the Earth. They're not far away like this picture was taken from. They're very close to the Earth. So just some interesting stuff. Patterns of stars in the sky are called constellations. They're used to label the sky. Did you know nearly 6,000 stars are visible in the sky to the unaided eye? If you're wondering how many stars are out there when you're looking around, it's about, well, there's about 3,000 in the northern hemisphere and 3,000 in the southern hemisphere. Of course, standing on the Earth, you can only see half the sky at a time, right? You can only see what's above you and to the side. You can't see everything on the other side of the Earth. So at any one time, you can see about 3,000 stars. That's a good little bit of trivia for you. In the ancients, you see, they didn't have TV, so they would lay there and they'd look at the stars and they'd make up stories. And they'd say, oh, that looks like this, and that looks like this. And there came to be beliefs that when you died, if you were some sort of hero or something like that, your body would go and become the stars. They didn't know what stars were. Had no idea what they were. Just lights in the sky. They didn't know what they meant. So maybe they're the souls of the heroes and such. And so they call those the constellations. There are 88 total recognized constellations by scientists. And here's one of them. Have you ever seen this one? This is called Orion. And this is what the sky looks like at a certain spot. And this is actually a very good picture. This, you wouldn't see it this colorfully with the naked eye. This is zoomed in a little bit. But have you seen Orion before? Have any of y'all seen Orion? I'm going to take you out to the beach a couple of times this year, and I'll show you the constellations. And I'll point to them, and I'll point them out. I have a green laser that can point at them, and you can see the laser going up, so you can tell what I'm talking about. It's really cool. You'll love it. Anyway, they thought this was Orion. Orion was the hunter, and there is what they projected onto the stars in their minds. This hunter that has a club, and he's clubbed something, dead thing, and he's holding it. Let me shut this door. Will you shut that door? Sorry. Scared our viewers. So that's one of the constellations. So this entire region of the sky is called Orion. And so the sky is divided up, like I said, into 88 regions. So over here, that's Orion, and over here, that might be Gemini, and over here, that's Leo, and over here, that's Sagittarius, and so forth. And the sky is completely covered with various constellations. Do you know your sign? What's your sign, Olivia? You don't know? That is awesome. I thought everybody knew their sign. Everyone that grew up in the 70s had to know their sign. Because that was big in the 70s. What someone knows there?
I know mine.
What are you?
Cancer.
You're Cancer?
July. And Virgo.
You're Virgo?
Scorpio.
Taurus.
Scorpio.
Sagittarius.
Sagittarius. Yeah.
The bull.
Very good.
Now look, the stars, these stars aren't actually close together. I mean, they look like they're close together from our point of view, but actually, if you measure the distances to these stars, like for instance, the three of them in the middle, the three belt stars, the middle star is way far away compared to the other two belt stars. Go back and look at that. Those three stars, they aren't actually right next to one another. That one's real far away, and those two are relatively close to one another, but that one's real far away. So just because they look close together in the sky in the constellation doesn't mean they're close together in reality. And they've discovered ways of measuring distances to these stars. And really the closest big one that we see is this one right here, which is on Orion's shoulder. Now the stars are named by Greek letters. Do you know the Greek alphabet? Alpha, beta, gamma, delta. Do you know that? Can you say it in less than 10 seconds? Alpha, beta, gamma, delta, sun, zeta, theta, gamma, mu, xi, kappa, rho, sin, delta, psi, phi, psi, omega. You had to do that to get in the fraternity house, or they'd beat you with a stick. Actually, I had to say it while holding a burning match.
Oh, I
3 times.
That's very last one.
So you light the match. Alpha, beta, gamma, delta, sun, zeta, theta, gamma, mu, xi, kappa, psi, delta, psi, phi, omega. Alpha, beta, gamma, delta, sun, zeta, theta, gamma, mu, xi, kappa, rho, sin, delta, alpha, beta, gamma, and you have to say that before it burned your finger. And see, I could say it so fast that when it came my turn, whoosh, I lit it. I kind of stretched a little bit. And they're going, "What are you doing? Say it!" And I'm like, "Just a second." And then I'd do it. And I'd easily have enough time. And then they'd hit me with a paddle anyway. But that was pretty cool. Pretty cool. So anyway, so Alpha, the Alpha star of the constellation, there it is right there. The Alpha star is the brightest star. The Beta star is the second brightest. Alpha, Beta, Gamma, the Gamma star is the third brightest, and so forth. So, so there's Alpha Orion is what you call that. You know what the name of that star actually is? The star itself has a name. It's called Betelgeuse. You ever heard that word before? Betelgeuse?
Not a movie.
There's a movie Beetlejuice, but that wasn't about stars, it was about a ghost. Yeah. Oh, a camp? Yeah. Yeah, that's a huge, it's a red giant. We call it a red giant. It's a real big star. And this one is called Rigel. You may have heard that too. That's a blue giant. And so stars have different colors, and they have different sizes. And their color and their size are based on different properties of the star, like how big they are, like how heavy they are. Really heavy, massive stars, or how old they are. Really old stars will start to expand. When a star gets old, it starts to expand. So, and when a star is real massive, it burns really hot. Blue stars burn really hot. Red stars burn really cool. Some stars are cooler than others. Isn't that interesting? We're going to learn all about stars in later chapters. But it's interesting to go look at all the constellations. I'll show them to you.
Why does the red star burn cool?
Because red stars are less massive than blue stars, and when you're less massive, you don't have as much gravity. And when you have a lot of gravity, when you're real massive, you have a lot of gravity, you pull your contents into the center, and it squashes them together in the middle of the star and causes them to fuse together, and it's the fusion that releases all the energy. So if you're a real heavy star, you're really pulling stuff in tightly and doing a lot of fusion. When you're kind of a light star, you don't pull stuff in so tightly, you don't do as much fusion, and you're not as hot.
So the color doesn't have
You wait,
how hot the star is or the size. I mean, like the sun is huge, but it's like red.
Yeah, the sun's actually not red, it's more yellow, which is in between red and blue. Yeah. And it's kind of yellowish white, which is a middle color. Blue is the hottest, red is the coolest, and white and yellow are kind of in the middle. And so our sun's kind of in the middle. If our sun was heavier, it'd be blue. And if our sun was lighter, it'd be red. Isn't that cool? Again, we're going to learn about stars. That's chapter 12, so that's a good ways away. But it is interesting stuff. Okay, so the constellations, there's a lot of them, like I said, and they exist on what's called the celestial sphere. And that's what this thing is. It's a celestial sphere. Celestial means stars, and sphere means big bubble. See, the ancient people thought that somewhere up in the sky, way far away, was a big plastic bubble. They didn't know what it was made of. But in this example, it's made of plastic. And they thought that the stars sat on the big bubble. And that the bubble spun around like this. So imagine that the Earth is a little BB at the very center of this. This is what the ancients thought. That the Earth sat at the very center, like in the middle. Like I can't get in there with my hand because of this. But imagine in the very center of this thing is a little BB. That's the Earth. The ancients thought the stars were somehow painted onto a large sphere that encompassed the entire Earth. And they called that the celestial sphere. And that throughout the nighttime, the celestial sphere spins. See what I'm saying? And that explains the movement of the stars across the sky overnight. In that the sun was also somewhere on this celestial sphere. And that the sun, you see, the sun doesn't stay in one place. The sun actually moves along the celestial sphere. Slowly over the course of the year, the sun moves through the constellations. And this is all wrong. There is no celestial sphere. And the sun is not moving. It's all because of the Earth. The Earth is spinning, you see. And that causes it to look like the stars are moving around. And the Earth is also orbiting the sun. And that causes it to look like the sun's position is changing. Do you see what I'm saying? So there is no celestial sphere out there, but the ancients thought there was one. So this is a model of the celestial sphere as the ancients thought existed. And it has all the stars painted on it, all the bright ones. And there's Gemini. And there's Cancer. Who said they were a Cancer? Ellie, are you Cancer? There's where your constellation is. And right next to you is Gemini. That's my constellation. And when were you born? July, and I was born May 23rd, so we're pretty close. And the thing is, this is why they're the signs of the zodiac. Wherever the sun sits during a certain time period, that's what sign you are, if you're born during that month. So the sun, on the celestial sphere, the sun sits right here in late May, in Gemini. And then the sun moves, you see, to Cancer in July. And then in August and September, it ends up in, where is it? Virgo? Is anybody Virgo?
They got on Pisces.
Yeah.
That's Libra, it's August.
Libra, here's Libra. So the sun's here, it's in August. Who's a Libra? Who? Carson's a Libra, so when were you born? In August. So in August the sun sits here, you see. And so it's the position of the sun at different times of the year that determines what sign you are. And you see, back in the 60s and 70s, used to always, everyone was into what sign you were. And they would, and that determined, like, you know, hey, what's your sign? And you'd say, oh, I'm a Virgo. And you'd say, ooh, I'm a Pisces. Virgo and Pisces like each other. Cool, man. That's
Just
how you
like
pick
that.
up girls back in the 70s. I was still very young at that point, so I didn't quite catch on. And then all that kind of got phased out. You know, your sign and your horoscope and all that, that's not so big anymore. People realize it's just nonsense. But back then it was kind of cool. So anyway, that's a celestial sphere. And again, the Earth rotates once each day. And so they thought the celestial sphere kind of rotated once each day.
Wait,
Isn't that cool? Here, I'll pass this around. Here you go.
So they have,
You'll grow me nuts.
do they have the constellations in the southern hemisphere too?
Yeah.
Then how do they
Stick out your
actually go
tongue
to
and
the
stick out your
southern
tongue.
hemisphere?
I know, I just have it
Do it.
Go back up.
Miss Marina.
Did they go to the southern
really zoomed in.
hemisphere to make more constellations? But people living in the southern hemisphere made up the constellations.
I thought these were only made by like Greek and stuff, people.
Oh, well, there were other people in the southern hemisphere that had their own names. It wasn't just the Greeks.
Oh, okay.
Yeah, the southern constellations have all their own names, and now we just recognize the names of the constellations now are not all Greek names. They're taken from a variety of names that have been given to the various constellations.
Oh, okay.
Wait,
Yeah.
you're over here, cause
You're reflecting the camera.
Okay, so here's how it shows it in the book. Here's the Earth, sits in the middle, and on the celestial sphere, the north celestial pole, there's a star there. It's called Polaris. Have you ever heard of the North Star?
November.
That's at the north celestial pole. So that's where if you follow the north pole of the Earth all the way up until it hits the celestial sphere, you'll hit Polaris. That's the star that sits right over the North Pole. That's the North Star. And it's good that it's there. The mariners use it to navigate. And you can always, if you find the North Star, you know what's north then, and then you know what's east and west and south. You see? So you can navigate by using the stars. That's how they did it. And the Big Dipper, you've heard of that, right? You can always find Polaris because these two stars on the Big Dipper point to it. So you find the last two stars of the Big Dipper there and just follow them, and that's how you find the North Star. Try it tonight if it's not cloudy. You'll see the Big Dipper go out just right at sunset. You'll see to the north. And you'll see the Polaris. Polaris isn't that bright of a star. It's a little bit dim. The south celestial pole doesn't have a star. So there's no south star. That's an empty area of the sky. Here's a time-lapse photo. This is pretty cool. Taken. You leave the camera open, the shutter open for 2 or 3 hours, and you can see Polaris, there's the North Star, it hardly moves. But the other stars move a long way. because Polaris is right over the North Pole, you see. And so as the Earth spins, it's not really moving. It just kind of stays in the same place. But the other stars move a good bit. Okay, so here's the coordinates they use to find a star. You have two coordinates. You have what's called right ascension, and you have what's called declination. Right ascension and declination. Declination is the degrees above or below the equator that the star sits in the sky. So Polaris, that sits right overhead, guess what the declination is of Polaris? How many degrees that is above the horizon? Can you guess? Come on, you guys are smart. 90 degrees, yes. Polaris is at 90-degree declination, plus 90 degrees. And guess, if a star was over the South Pole, guess what it would be? If this is plus 90 degrees, minus 90 degrees would be a star's declination that's over the South Pole. So to find a star, you can apply a number that's called declination, and it's in degrees. And so if it was 45 degrees up in the sky, not quite all the way to the Polaris, but definitely above the equator, 45 degrees, that's the declination we'll give that star, to locate it in the sky. Every star can be located in the sky with two numbers. Declination is the degrees above or below the equator, and what we don't call it the Earth's equator, we call it the celestial equator. And the other number that you use to locate a star is called right ascension. Say it after me. 1, 2, 3. Right ascension.
Right ascension.
Let's try it again so everybody says it at the same time. Right ascension.
Right ascension.
That's right. Right ascension is left or right. And you go left or right of, it's just like longitude. You know how there's latitude? Declination is like latitude, and right ascension is like longitude. And it's measured just like longitude is. It's measured in hours, minutes, and seconds. So you take the zero longitude, which goes through what? Do you know what city zero longitude goes through? Greenwich, England. Okay? We set zero longitude at Greenwich, England. And if you go one time zone over, you're plus 1 hour. And if you go 2 time zones over, you're plus 2 hours. Do you see what I'm saying?
The 45th parallel is like 20 minutes from where my house is in Michigan.
Is it really?
Yeah. There you
Very
drive
cool.
through it and there's a sign that says
Yeah.
45th parallel.
Do you know what we're at? You know what latitude we're probably at, right? Do you know what latitude? There's a place called Latitudes.
220 something.
Yeah, it's 22, isn't it?
Yeah.
Yeah. Latitude 22
Redford.
in Redfern,
It's
latitude.
across from Waco.
No? Don't know about that?
That's catch 22.
Yeah, that's catch 228.
There's also a restaurant. There's,
It's on Jekyll. It's on Jekyll.
Shut up.
Is it 31? I can't remember. They have a number on the
It's called
restaurant.
Latitude 331 is the name of the restaurant.
331?
No, just 30.
Is it 31? So we're probably at latitude 31. I think the longitude is, I'm not sure what the longitude is. Anyway, you go 1 hour for one time zone, 2 hours for 2 time zones, and eventually you get all the way around the Earth 24 hours. You see what I'm saying? 24 hours will take you all the way around the Earth. So that's how right ascension is measured, in hours to each side of the zero longitude line. And so if here's a star in the sky at 45 degrees declination, plus 45 degrees declination, and 6 hours, 22 minutes, 3 seconds to this side of the zero longitude line, then that's the location of the star. And you can locate every star by using those two coordinates. And so they find the star, and there are little computers now that can locate the star, through a telescope or something like that. and it'll figure out the right ascension and the declination exactly, and you can chart that in a computer. So every star out there in the universe would have a certain right ascension and a certain declination from the Earth. Does that make sense? You read 0.1 tonight. You're learning stuff. Did you cut it off?
Mm-mm, not yet.
Let's cut it off.
Okay.
That's who filmed. Leah, look.